I'm Stephen Foskett, the organizer of Tech Field Day, and we are here in lovely Silicon Valley for Storage Field Day 11. The video you're about to see is a discussion between a panel of invited social media influencers, bloggers, podcasters, writers, speakers from around the world who came together with interesting companies in their space to listen to presentations, but also to interact. If you'd like to be part of this, please go to techfieldday.com. You can learn more about becoming a presenter or a delegate at a future Tech Field Day event. You can also find videos like this one on our YouTube channel, which is youtube.com/techfieldday.
My name's Phil Sciuto. I'm Director of Solutions Architecture at HGST. And we're talking about object storage. And obviously, as an old IT guy, object storage or storage in general tends to be a very conservative aspect. Folks typically don't change because of emerging technologies. They generally have to be, compelled to change to move into new technologies. Certainly in this first slide, we talk about, some of the motivators and the factors involved with organizations looking to embrace object storage as a new storage tier in their overall storage architecture. The first two statistics come from IDC. The last one comes from 2 semesters at UCSD that my parents will be gratified. That one's mine. I worked really hard at that one.
Good ROI.
That's right. 100% of customers surveyed need to preserve valuable data. I stole the next part of the slide from Gary. But it does really focus, I think, on what's important. That and one of the compelling factors around driving organizations to object storage is that capacity shipments are being exceeded by the demand for more storage. Traditional storage solutions aren't working. They're not big enough, fast enough. Or, as Rourke pointed out on the whiteboard, customer organizations want that data. They want access to that data. They don't necessarily want to put it to tape because once it goes to tape, it's no longer useful. Longitudinal data is important. It's a lot of verticals, a lot of applications. Having the ability to analyze data over time is important. However, there is that early 30, 60, 6-month period where data is very active, but after that period, you still want to access it. You don't want your data to go away. So we're seeing that transition. That's another slide I kind of paraphrased and stole from Gary. We're moving away from data center silos and moving into a more stratified storage architecture where we have different levels of architecture. But I think the overall takeaway and really where a lot of enterprises are looking to move is to an environment where data never dies. Data never goes inactive, but it just moves to a place that's more cost effective and fits their overall business model. Another big factor, data is exceeding budgets. Budgets aren't growing. We hear it about it in the news all the time. Wage stagnation, budget stagnation. However, the demand for more and more storage continues to exceed those budget numbers. And lastly, there's a technological limitation. Not only is the capacity or the demand for storage increasing, but storage density is as well. It's commonplace now to see 8 terabyte drives. We're shipping our current active archive with 10 terabyte drives. Certainly larger drives will continue to come out in the future. Over on the left, there's a chart that I threw together a while back. Now, obviously, this tends to ignore smart technology and some of the technologies that are built into the disk. But one of the things we know for certain is that the density of a single disk exceeds the error rate of the disk substrate itself. And so what that ultimately means is that with older technologies like RAID that don't have good protection against bit rot, sooner or later, and what these statistics on the right-hand side, and everyone knows I'm a master of statistics, I pointed that out on my first slide, is that if you do lose a disk in a RAID array with large, high-density disks, there's a very high likelihood that system or that RAID array will fail on rebuild. Certainly anybody who's run any kind of storage array in operational capacity based on RAID knows as soon as the disk fails, the alarms go off, you're sending a guy out there, you're changing that disk right away, and you're holding on tight for the next 2 days to 2 weeks while that array rebuilds, waiting to make sure you don't hit an unrecoverable read error. So one of the differentiators with object storage, and certainly with our Active Archive platform, is the ability to move away from RAID and into erasure encoding as a method of data dispersal. Question over there.
Do you think that's a differentiator?
I'm sorry, not necessarily. Erasure encoding itself isn't. And so one of the things, part of this talk is really to, there's going to be some things that are fairly common across object storage. Not really spend too much time on that, but we do want to point out some areas where we think our technology is leading the way and really differentiating. And while erasure encoding itself isn't, our approach to erasure encoding is.
Okay.
And we're going to...
I'll let you finish then.
Yeah, okay. So one of the things that we do, and actually the next slide is a great segue into this, is obviously erasure encoding, and this is pretty much true across the board, gives you a higher level of durability. Our system gives you 15 nines. So it really is a much higher level of durability than you could achieve from RAID. We have a technology called fail in place, and I'll go into that a little bit deeper in the next slide. The ability to recover rapidly from a drive failure, because you now, in the case of our active archive, where we have 588 disks in that appliance, if you lose a disk, the other 587 go to work rebuilding it, which means that recovering from a 10 terabyte disk failure is a matter of hours, not days or weeks. And lastly, bit rot protection, and this is where Bit Dynamics, one of the key values of the Bit Dynamics technology we have built in, is your system is constantly undergoing consistency check of your data at rest. If it sees a problem, you can utilize that erasure encoding technology to re-land that corrupt chunk somewhere else on the system and mark the data that where it was sitting that suffered from bit rot or corruption at rest, mark it bad, and go on its way. This just happens automatically all day, every day. But to talk about why our erasure encoding is different. Most of you are familiar with Reed-Solomon, which is a deterministic, and typically in these ring-based object storage type solutions, there's a deterministic mapping. You give me a path, I can tell you where that data lands. Now the problem with that, there's two problems. One is you've got a very chatty customer, you've got someone who's really doing a lot of activity in a single location or a single path, you can run into drive hotspots, where you've got a very small percentage of your drives getting beat up while the rest of it's sitting there idle. The other problem that can run into is if you have a drive failure and it's part of that area that's being accessed, you'll have some really significant performance impact until that drive is replaced. So really you haven't gotten away from that sense of urgency when a drive fails. It's just shifted and you've gotten some more durability protection around it. With our system called BitSpread, it's a dynamic allocation and data dispersal method. So we get the first object that comes in. We've got really cool, this is where the multimedia presentation comes in. It gets the rateless erasure encoding is applied, and it's committed to disk. We have certain rules around how that data is dispersed across the disks, no more than one chunk per disk, no more than 3 chunks per chassis. It gives us a high degree of resiliency at both the disk failure level or the appliance or component level failure. We get a second object that comes in, could even be the same object, just getting overwritten with a new version.
So is a chunk like an extent or?
So in this case, no. The object, we use an 18-piece encoding process. So when an object comes in, it gets broken up to 18 pieces. Each one of those chunks will get encoded and dispersed off into the disks. We can either,
So a chunk is an object entity, not a block entity?
Correct.
Okay.
Right. It's the application level. And then we can recover some subset of those chunks in order to rehydrate the data into an object, depending on the protection policy you apply. But the key takeaway here is, because of the dynamic nature of that dispersal, that same object, every time it comes in, the system will look at its available disks. It will look to see which ones are busy, which ones are less full, which ones are broken, and disperse that data to the appropriate places to maintain high performance. One of the points of pride for me on the solution is that everyone's going to tell you their object store works great and performs well when it's healthy. One of the things I like to say about our system is come see it when it's got a bad disk. It performs equally well.
Can I just ask you a question?
Sure.
Because I thought that was kind of the point of all erasure coding, right? Or Reed-Solomon-based erasure coding, right? Is that, you've got, N and Y or X and Y or whatever, and that reading, that if I'm missing some of the Y, I should be able to read the entire thing without that missing Y
Sure.
at the same performance because I could read any, in your case, 18, what did you say, 18 of
18, so 13 of 18.
Yeah, so any 13 of the 18 should give me what I need. So as long as 13 disks reply,
Yes.
why would the fact that one of my 18 disks being repaired affect that?
At least in my experience with some of the other competing solutions before I came to HGST, in practice, what we would find out is that a lot of those calls would wait to time out to see what was going on with that drive. They're constantly looking and hitting that drive to see if it's alive. Until we replaced that drive, we saw significant performance impact. And then now, to be completely candid with you, it's been a couple of years. I've been at HGST, and I haven't really dug into the technology as it currently stands. But at least anecdotally, from what I understand from some of the folks in my sphere of influence, that continues to be an issue. And certainly, one of the other aspects is when you look at changing that ring file, adding or removing storage, it's going to do a reshuffle of the data. And you're going to start to get all sorts of east-west traffic across your storage. That's another benefit to this solution, is that adding storage doesn't change what's already landed on the disk. This pretty much just summarizes some of the items we talked about on the previous slide. No single points of failure, no hotspots, systems auto-corrects for both failures and corruption at rest. Oh, and lastly, we're doing this because of the erasure encoding over 3-copy replication. We've got a much lower disk overhead impact to the raw versus usable storage than you're used to seeing in 3-copy.
How many nodes can you scale to?
How many what?
Nodes, appliances.
But it's really just a limit. I think, there's a number of different ways we scale out.
Okay.
But certainly in this dispersal model, so from a single object coming in, how widely we disperse it, the number is somewhere over 3,500 disks before we'll just build another column and then abstract out the namespace above both of them.
So the namespace can kind of scale?
Sure. The name scale, yeah.
How it can scale infinitely, or is it?
Essentially.
Okay.
So yeah, the namespace lives above each of these dispersal zones. And we've really artificially limited it to 6 racks of disk, which is, like I say, it's 3,500 and something, 588 times 6.
Sure.
And really the reason behind that was, at that point, every controller node, every node that's receiving those objects now can reach into those disks and spread it out. And ultimately the east-west traffic across the racks starts to be excessive. And certainly that dispersing across 3,500 disks is a level of durability that adding a 7th rack makes no sense. So we just start building out new dispersal zones beyond that. Scales up to hundreds of petabytes.
Okay.
Yeah, I mean, otherwise, while we'd start to run into the requirement of exceeding the capacity of the top of rack switches and having to go to a core switch. And really for us, it's as much, a part of the low operational cost is to eliminate, make this a turnkey solution that the customer can drop in, not have to add a lot of complexity around. One of the customer examples we have is an ISP in New Zealand called Rivera. For them, there was a number of important factors in looking at an object storage solution. One was that New Zealand happens to be very earthquake prone. In fact, they just had a major one. So for them, having this 3-zone deployment across, widely dispersed across the islands of New Zealand, gave them the level of resiliency so that they can continue to function even with the failure of one of their 3 locations. Cost was obviously a driver. The ability to scale up as their demand and the ability to easily grow out and scale out the solution without impacting their customers. And lastly, we didn't really touch on it, but immediately consistent. So our solution, unlike a lot of them, when an object comes in into a 3-node cluster, 3-site, if site A receives it and a request goes into site B, it immediately gets the new data. There's no eventual consistency model. There's no concern about getting stale data. And so for them, it made that global load balancing model that they put around this and the ability to withstand a site failure a much more palatable, much easier to sell model for their customers because any site they go to, the data is identical.
You may win the award for the smallest font ever on a slide.
Yeah. Sorry about that. That's actually a screen grab off of their webpage. So unfortunately, I tried blowing it up and it wasn't any more readable. It just got blocky and kind of sad. Question?
I think I'm putting the pieces together, but can you elaborate or re-explain on how that immediate consistency is possible?
Sure. So you're probably, you're familiar with a 3-copy policy. You're familiar with how typically those work, but the eventual consistency where site A will receive the object put, it'll ACK it, it'll send back a response, yeah, got it, and then it'll queue up that object to be replicated to the other 2 locations. But ultimately, you're sending 100% of that ingested data to the other 2 locations. With our system, that location will grab it, will do that erasure encoding, will store 6 pieces locally, and send 6 pieces to each of the other 2 locations. Once it gets an ACK back from those, it will then send back the success response to the customer. Ultimately, once that happens, and because with a 3-geo deployment, we're doing an 18-8 encoding policy, meaning we can lose up to 8 pieces and still rehydrate the data. We have 6 pieces each location. We can lose any one of those 3 locations and still have 12 pieces to pull from. The system is smart enough to know that it will pull its local copy, local pieces first. So read responses tend to be much faster because we're only pulling 4 pieces over the wire instead of all 12.
And obviously that's going to come with a performance hit on writes.
Absolutely.
You're having to wait for that,
sure.
Right? That's the downside to
It absolutely is. However, if you look at their use case, and I don't know if it's actually in the bigger print over on the side, if you look at the tiny font, but one of their overarching requirements as part of this installation was something I like to refer to with customers as the vulnerability gap. In those eventual consistency models, you get the data locally. You send it to that first site. It acts back, success, got it. Like I said, they're very seismically active. And for them, what they didn't want to do is send a success response back to a customer, have that site go offline, and the customer go, "Where's my data?" Because I already evicted it off my local system because you said you had it. So for them, that resiliency of data, that immediate resiliency of data before they sent back the success response to the customer was more important than the performance improvement or the increase of a eventually consistent model.
Just curious, is there a white paper that describes the structure and architecture of this?
Absolutely, yeah.
Okay, great.
Another example of where we've deployed this successfully is in the media and entertainment space. Couple of different use cases. The top one, Montrose Jazz Festival. We also have a motion picture studio and a sports franchise, and they're using it for media content archive. Another case of typically in the past they would have taken that information and moved it to tape, but they really want to consume it. You think about a sports franchise, they're consuming and they're generating just boatloads, huge volumes of media, and they want to go back and review it. They're using it, more and more. Their content-driven analytics. They're using it to improve their team. They're using it, in the case of Montrose, they're using it also as an origin point to distribute that data to others. Having it in a cost-effective manner, in an active archive rather than a cold archive, has given them a tremendous amount of flexibility and capacity and competitiveness that they didn't have prior. The second one, the broadcaster, a lot of folks in the market, tend to think of object storage as being slow. There's a really good example of a major broadcaster here in the United States that's using this as a transcoding target. So they're taking their original content, they're transcoding it to over 15 different formats for distribution across their CDN. And because they're constantly improving and changing those formats, they're also going through about quarterly and retranscoding the entire asset library they have. They found that with the active archive, they have enough performance to perform that, as well as use as an origin point to their CDN. So it's not just deep, it also happens to perform quite adequately for some of those use cases that rise up above what people would traditionally think object storage is good for. So really in summary, talked about some of the what we think of as being those unique Differentiators that set us apart from some of the traditional object storage and where we're going from here, extremely large scale-out capabilities. In that single data dispersal model, 35 petabytes, we can obviously scale beyond that. Our GeoSpread technology, which allows us to provide site-level redundancy and resiliency. The rateless erasure encoding that allows us to dynamically land that data on the best, fastest, least used disks. BitSpread and BitDynamics, which allow us to have the highest durability out there in the market. And then immediately consistent, which is part hand in hand with a 3GO. And lastly, and I didn't really touch on, we ship this system, let me go to the next slide where you can actually see it. We ship this system like this. It comes in that. It's a shipping container. It's also a rack. If you look behind it, it's fully wired. It's fully configured. It's ready to go. I've been with customers on site where we rolled it into place. You plug in 2 power whips, you plug in 6 optic fibers, and 2 hours later, customers are on it active. And that's for 3 petabytes of usable storage. Back in a previous life, 8 years ago, I did 4 petabytes in Los Angeles, and it took us 6 person weeks to install and configure. So it's not just easy to install, it's also easy to operate. Those things like that fail-in-place technology means they're no longer sending folks out at 2 in the morning to change a disk. They're changing a disk every quarter or semi-annually, depending on what their failure levels are like. Yeah. Go back to, harken back to that earlier slide where we had those different stratification of the data center. Now that we're partnered up with SanDisk, HGST, and Western Digital in general, you're starting to see us covering the whole spectrum of solutions, from the very fast local direct attached storage down to the very deep and dense active archive, and continue to move in that direction. Any questions?
Have you got any mechanism to kind of tier data on and off with automatically, like an
Sure.
tiering mechanism?
There's a number of solutions we partner with.
Okay.
One of the things we have touched on, we have a dedicated team that focuses on nothing but partner ecosystems. And we have another group that I'm a part of, the technical marketing group, that really works to ensure that those solutions are well vetted, that they work, they're certified, and we have cookbooks for a lot to help our customers to integrate those solutions together. In the particular case, we work with vendors like iRods, Versity, Nirvana, a number of other tiering solutions, whether they're hardware or software, for customers, and it really just depends on the use case.
Sure.
But yeah, I mean, I think Gary mentioned it earlier about ILM, but my joke is I've been in the object storage world now for close to 6 years, and I've had one customer come to me and say, I just want object storage. Just give me some of that object storage, and it's good enough.
It's always a piece of the puzzle, right?
Yeah, usually people come to you with a problem, and then they're looking to you to help them utilize various pieces and parts of technology to solve that problem. And so, yeah, it's unfortunately, while I can sit here and talk chapter and verse about object storage, when I usually talk to customers, it's a much higher level, and it's just a piece of the puzzle.